All right, this is day 11, and this lesson will be yet another lesson pertaining to circles and specifically the relationships between angles and the arcs they intercept. Just as a quick review, there were four basic relationships that you definitely have to memorize, and once again, they are when the vertex of the angle is at the center, the angle and the arc measure are equal. That's called a central angle, by the way. When the angle is inscribed, meaning its vertex is on the circle, the angle is actually half the arc measure, or you could say the arc is double the angle. When the angle is floating around here in the interior of the circle, we have to use the two intercepted arcs. So the angle is actually equal to the average of these two arcs. So of course that means we are going to add them and divide by 2. So angle equals arc plus arc divided by 2. And in a similar way, when the angle is outside the circle, again we will need both intercepted arcs, but instead of adding like we do when we find the mean or the average, we will subtract. Just be careful, you have to make sure you're doing the big arc minus the small arc, otherwise you're going to get a negative number. So please commit these to memory if you have not already done so. I have created some flashcards to help you. If you go to Quizlet.com and search for Mr. Helpful, you will get a list of all of the flashcards that I have made for my classes, and this is one of them, circle, angle, arc formulas with pictures. So just go and quiz yourself, what is the arc-angle relationship? Which one was this? Angle equals arc, big arc minus small arc divided by 2. Click on that and it gives you the answer. Okay, so come to the website and quiz yourself on those flashcards. I may even add a couple. Anyway, back to the lesson. So looking at today we're going to do the evens. We did the odds on a previous lesson. I believe it was day 9. So if you are curious about the odds, then take a look back at day 9. Anyway, so here we are on day 11, so I'm going to do the evens. So problem number 2 then, if I want to find the measure of angle A, technically it's going to be a two-step process. First, I will find the measure of arc BC, which goes like this. Okay. Well, this angle is at the center. That means the arc should be the same as the angle. Now, if I want to find angle A, which is what we're supposed to find, I can see that angle A is an inscribed angle. So the angle should be half of this based on the formula that we just talked about. So half of 132. So that's why angle A is 66 degrees. Okay, number 4. Finding the measure of angle C. Okay, see, something pops in. There's like so many different ways to do this, but I'm going to show you 2 ways to do this problem. I think it will make you smarter if I show you both ways, so that's what I'm going to do. All right. Here's one way to do it. I see this 28 degrees, and I see that it is an inscribed angle. Okay, so when I look at this 28 degrees, and I look for the arc that it intercepts, and I know that the arc should be double. Okay, so what was that, 56? So that tells me that arc BC is 56 degrees. Now what I can do is, because AC is a diameter, that means I've got a semicircle up here. So I should be able to find arc AB with no problem because it's a total of 180, so I should just be able to do 180 minus 56. And that should give me arc AB, which is 124 degrees. Now I'm in a position to find what I was actually supposed to find. I'm supposed to find the measure of angle C, and angle C is over here. All right, just to make it clear, let me get rid of that green so we can focus better. Okay, so angle C is now this. Okay, and this angle should be half of that arc, 62 degrees. And that's what we were supposed to find. So the measure angle C is 62 degrees. And we are done. Okay, but I do want to show you another way of doing this problem. I'm going to get the same answer. All right, so starting over. I need you to see for this perspective, whenever you have a circle and with radii like this, what you have is an isosceles triangle, because both of these green lines are radii of the same circle. So, you know, the radius in any direction is going to always be the same. So that creates this isosceles triangle here that I've shown in green. And an isosceles triangle has the property that the base angles are congruent. So angle A here and angle B should be the same. So they're both 28 degrees. Okay, base angles are equal, so you see that immediately. But you know that a triangle has to add up to 180 degrees. So I should be able to find, let me switch colors for a second. I should be able to find this angle right here very easily by doing 180 minus 28. Whoa, wow, okay, minus 28. Okay? And that is 124 degrees. Now, because this is a central angle, the angle and the arc are the same, so this is also 124 degrees, arc AB. And so now I can finally go ahead and find angle C. All right, which angle C is I'm showing here in red. Angle C is an inscribed angle, so it should be half of this 124. Okay, if I divide by 2, and of course that is going to give me 62, just like we got before. All right, I think the first way was a little shorter, but that thing about having an isosceles triangle and seeing the base angles, you never know when that's going to come up and be necessary. So I definitely want it to be somewhere in your brain, even if you wouldn't necessarily use it on this problem. All right, moving on. Number 6. We are supposed to find arc BC. So arc BC here is our target. We're given this angle up here to play with, but to get closer to BC, I would really like to know what this angle is right here. Well, let's use the fact that, wow, I'm trying to draw a straight line with this digital pen. It's a little tricky. That green line is a diameter. It's a straight line. That means the two angles that form it should make 180 degrees. So I can find this angle right here. It should be whatever I get by doing 180 minus the 138. So I'm just going to subtract. Okay, so that is 42 degrees. Well, if this is 42 degrees, seeing as how this is a central angle, then arc BC should also be 42 degrees. So that's how you do number 6. All right, let's take a look at number 8. All right, our target is angle A. That's what we're supposed to find. as soon as I see this 94, I know that this is 94 degrees over here. You know what? I mean, there are other ways to do it, but I think the quickest thing to do on this problem would be actually I lost it now, but the thing I just showed you about isosceles triangle will be very helpful right now, because this is an isosceles triangle right here. Okay, see these two radii? They will be the same. So that and that are the same, which means that these base angles are going to be congruent. Okay, so I guess I should complete the triangle. So this is my isosceles triangle. So if I subtract 94 from 180, so 180 minus 94, okay, so far that gives me 86. So that leaves me 86 degrees to share equally between these two base angles. So I'm just going to divide that by 2, and of course that's going to give me 43. So each one of these angles is 43 degrees. So that's 43, and that is 43. But bam, angle A, that's what I was supposed to find, is 43 degrees. Okay, I think that is the quickest way. I could have, looked at the diameter here, subtracted 94 from 180. I could have found this right here, which would have been the same as this, and then I could have divided that by 2. That would have been the other way of doing it. But I like this way best. Shoo, number 10. What's up, number 10? Oh, it's a group of problems. Okay, find the indicated measure. Arc CD is 85. Wait, where's the picture? Oh, there it is. Okay, arc CD is 85. Let me colorize this a little bit. All right, and we're also given that arc BE is 97 degrees. And using that information, we're supposed to find these things. So number 10, find the measure of angle ABC. All right, I will paint our target in red, angle ABC. ABC is this angle right here, A to B to C. Okay, that is the angle that we are supposed to find. Well, guess what? 90 degrees. Boom. How did I know that so fast? Well, look at the fact that AC is a diameter. Okay, from A to C here is a diameter. Because it's a diameter, that means we're looking at 180 degrees. I mean, this is a semicircle over here. Okay, so we'd know that that is 180 degrees, and so this should be half of 180, so that's 90. So that's 90 degrees. Thank you very much. All right, number 12, BDE. Start that over again. Okay, BDE is like this. BDE. By the way, I want you to note my use of colors and things and tracing and highlighting. If you're doing problems like this, I highly recommend you do the same. Get yourself some markers, colored pencils, whatever. At least trace it with your pencil or pen. It really helps you see what's going on. So this is pretty straightforward. Once you color it, this is an inscribed angle. It should be half of the arc that they gave us. So it's just going to be 97 divided by 2. Okay, so it'll be a decimal, but that's okay. 48.5 degrees. Okay, next, ABD. Okay, this is the angle that we are supposed to find now. Okay, ABD. All right, well, for this problem, this 97 degrees over here is really just distracting us. So I'm going to erase it for a second. And instead, I want to focus your eyes on the semicircle again. So this is still the diameter, which means that this is still the semicircle. All right, I'm going to not go out all the way so I can still trace it on the outside. But this is a semicircle here. And notice that I'm given this purple part of the semicircle is 85. So I should be able to quite easily find this green part of the semicircle by subtracting from 180. So if I just did 180 minus 85, so which is going to be 95. Okay, so this green arc here is 95. All right, they have to add up to 180. Why did I care about that? Because now, let me get rid of this so you can focus yet again. The angle, the red angle here that we're supposed to find is inscribed. It's touching the circle, so it should be half of this arc. So just 95 divided by 2. So that one should be 47.5 degrees. Okay, 47.5 degrees. Okay, next we have arc AD. Wait a minute. We just found arc AD as part of solving for the last problem. So arc AD is 95 degrees. We already figured that out. So let's just write that down. 95 degrees. Okay, I think that's it for this group. So let's move on. Let's find number 18. Okay, determine whether a circle can be circumscribed around this figure. Well, this one is pretty obvious that it's no. When they talk about circumscribing a circle around a shape, they mean, can you draw a circle around the shape so that all three vertices, well, or however many there are, but all the vertices have to be on the circle. So if I draw a circle that's touching these two vertices, there's no way it's going to reach the third vertex. It's just obviously a no. That's just a insta fail. However, when we're dealing with quadrilaterals, we can do a little bit more math with it. If the principle for a quadrilateral, if there's going to be a circle that you can circumscribe, then these opposite angles should be supplementary. Okay, they should add up to 180. Now I can tell from the 5 and the 3 that that's not going to end in 0. So this is going to be a no. This is going to be a no because these two angles, 115 plus 63, that equals 178. So it's close, but no, it's got to be a 180. All right, that is the second to last problem. Now we need to look at problem number 22. Oh, it's big. It's a big one. Got to back it up. Okay, number 22. Number 22 has an extra level of challenge to it because it is really two problems in one, and you sort of have to solve it in the correct order. So for the first problem, you really want to ignore the y. Okay, and I might even erase it just to make a point. For the first problem, you want to ignore the y, Okay, so for example, I'm doing this. Just pretend like nothing see here, folks. Just pretend like this is not even here. This is all going away. Okay, just ignore it. And just solve for the x. Okay, that looks much easier. What situation are we in? Well, remembering our formulas, we are in the third situation where the vertex is in the interior of the circle. And we know that the angle is equal to the arc plus the arc divided by 2, the average of the two intercepted arcs. So that's the situation that we're in right now. So the two intercepted arcs that we're talking about are the x arc, and then there's this, okay, I'm not doing this very well, but there's this 142 degree arc that goes around like this. Those are the two arcs that we're talking about. So please remember that this is the angle right here. It's the only angle in this picture. All right, so the formula goes angle equals. So we will not start off with x equals, as tempting as that is. We will start off with 93 equals. All right, it's always angle equals. So angle equals arc plus arc divided by 2. All right, so the arc plus the arc, that is x plus 142 divided by 2. So to solve this, we shall multiply both sides by 2, like this. So those will cancel each other out. So that gives us 186 is equal to x plus 142. Time to subtract 142 from both sides. All right, so that's going to give us x equals 44. Okay, so that is one of our variables. All right, now we have to go back and find that other one. So let me bring back all the stuff I just deleted. Okay, now we have to find angle y, but this time we know what this x is. So it's no longer a mystery. X is 44. Okay, so I can put a big old 44 right here because that's what x is. So notice now I have both arcs. So when I look at angle y, in terms of formulas, of course, we're in the fourth situation. And again, we need both of these arcs to do it, and it's going to be the big arc minus the small arc divided by 2. So that's how we will find y. We have to do the big arc minus the small arc divided by 2. Notice the small arc is x. We just found it, so we had to find x first, and then we can use it to find y. So now we can go on and finish the problem. So the angle equals big arc minus small arc divided by 2. So 142 minus 44 divided by 2. Okay, and this you can just put in your calculator, and that's going to give you the answer. Turns out to be 49. Okay, so y is 49. All right, that's it for this lesson. I hope it's been helpful to you in some way. If so, please go ahead and give me that thumbs up. I really appreciate the like, and I will see you on the next video.